Okay, 6.3 is on vectors. And as you remember from Despicable Me, vectors have a magnitude and direction. The magnitude is the length, and the direction is theta. It's the angle that it makes with the x-axis, and we'll get into that in a few lessons. But let's look at a typical vector. It has an initial point, also called a tail. It has a terminal point, also called a head. Initial point has just a dot. The terminal point has an arrow, and that's how you know it's a vector. This is called vector PQ. So PQ, and you indicate it that it's a vector with a little arrow above it. Now, how you get the components of the vector, you just count in the x direction from the initial point. So we'll get 1, 2, 3, 4, 5, 6, 7. So it's 8 in the positive x direction, and then 3 in the positive y. So the way you would write this vector, PQ, is you use the brackets. Well, I guess it's not a bracket. It's a less than signal. And you put 8, comma, 3, and then a greater than bracket. And this indicates that this is a vector. And you won't be confused by if you have coordinates of 8, 3. This is just an xy coordinate with the parentheses, but with the greater than and less than, that means it's a vector. So here we're talking about the component form of vector is equal to, when we say v1, v2, this is the delta x and delta y. But it's more common just to put it in this form like we did right here. So let's do an example. So example 1, find the magnitude of the vector with the initial point P, which is -2, -3, and the terminal point Q, 3, 9. So when you're plotting vectors, just do a little indication like this. Put just a cross where the origin is. You don't have to draw the x and y axis. So, but we do need to know where the origin is. So -2, -3 is right here. And then 3, 9, so 3, 1, 2, 3, 4, 5, 6, 7, 8. So here's 3, 9. And this is -2, -3. And now we just want to, this is point P, and this is Q. So now we just want to draw the vector. We don't have to draw it to find the magnitude, but it's helpful to draw it. So we're just going to draw the vector here, put a arrow there, and this is vector PQ. So what do we want to do? We want to find the magnitude. Well, you can use the direction formula. PQ is equal to the square root of x squared, x2 minus x1 squared plus y2 minus y1. So if we did that, x2, usually use the terminal point as the x2, y2. So you don't have to, but it's just kind of easier to remember it that way. So this is going to be 3 minus a -2 squared plus 9 minus a -3 squared. So 5 minus, so -5 squared is 25 plus 9 minus -3 is 12 squared, 144. That's the square root of 169, which is 13. So this is the magnitude of PQ. Now, another way to do it is just graphically. You can count the squares. So in the x goes, well, you're going to right here. So 1, 2, 3, 4, 5. So we got 5 over, and then we go 12 up, and then we didn't do that very pretty, but you get the idea. So this is 12, and from, do it in red, from here to here, that's 5. So you can get it the same way. And remember, the magnitude is just the length. So the length of this PQ is 13. Okay, resultant vectors. When you add or subtract vectors together, you're going to get a resultant. And let's look at vector u right here. Here's the initial point right here, and the terminal point is right here. Now, when we add vectors, like we're going to add v to u, so it looks like a u plus v. We add the tail of v to the head of u. To get the resultant, then we just go from the beginning of u, the tail of u, to the head of v. And so I'm going to draw in the resultant vector right now. And this is the resultant vector, sometimes called r. But how do you do it algebraically? Well, let's look at u. Let's look at what vector u is. U is 2, 3. 2, 3. And v is 3 minus 2. V is 3 minus 2. And so to add them, what you're just doing is adding the x components and the y components. So u plus v is 2 plus 3 is 5. That's the x components. 3 minus 2 is 1. So this is the resultant vector, r. And if we just go from r, the beginning of r, to the tail of r, we can see that it goes over to the right 5 and up 1. So that's the resultant vector. So let's do an example with that. Let's say, let's look at example 2. Let's say u is 1, 2, v is 3, 1. So we're going to add u and v, and that's equal to 1 plus 3 is 4. 2 plus 1 is 3. So there's u plus v. Well, what about u minus v? Well, u, so it's 1 minus 3 is a minus 2. And 2 minus 1 is 1. So this is u minus v. The other thing we can do is we can multiply vectors. So we have a 2u minus 3v. So this is going to be 2 times u, which is 1, 2. And then we're going to subtract 3 times v, which is 3, 1. So that's going to be, we multiply the 2 times the 1 is 2, and we're subtracting the 3 times the 3 is 9. So we get a 2 minus 9 is a minus 7. And then we have the 2 times 2 is 4, minus 3 times 1 is 3. So 4 minus 3 is 1. So this is 2u minus 3v. Okay, let's define what a unit vector is. This is a vector that has a magnitude of 1, and it has the same direction as the original vector. So if we're looking at vector v here, and we know the magnitude is greater than 1, so if we wanted to know what the magnitude is, we just count the squares, do Pythagorean's theorem. So it's 1, 2, 3, 4, 5, 6, 7, 8. 8 to the left and 2 up. So the magnitude of v is the square root of 8 squared plus 2 squared. But we want the unit vector, and so what that means, it has a magnitude of 1, but it goes in the same direction. So it starts here, and let's say, this is probably a little bit long, but let's call this u, assuming the length of that is equal to 1. And let's do an example of that. Example 3. Oh, before we go on to that, we have a formula for finding a unit vector. U is equal to v divided by the magnitude of v. So the double absolute value signs means magnitude. Okay, so let's go to example 3. Find the unit. So we confirm that it is a unit. Okay, so let's go to example 3. Find the unit vector u of the vector v, which is 7, negative 3. Okay, so we just put it into the formula. So the vector v is 7, negative 3. And the magnitude is just the square root of 7 squared plus 3 squared. Now the thing to remember, it doesn't matter that it's a negative 3, because when you square it, it's going to be positive anyway. So I just write this sign here, just make it positive. So that's equal to 7, negative 3 over, so 7 squared, 49, plus 9, 49 and 9 is 58, so it's square root of 58. But then we want to break it up into the x and y components. So we just say this is, it's still a vector, so it's a unit vector. U equals 7 over square root of 58, comma, negative 3 over square root of 58. So that's the unit vector. So let's just see if the magnitude is 1. So I'll work over here on the left-hand side in red. So what we want to do, so we have 7 over square root of 58 and negative 3 over square root of 58. We want to find the magnitude of that. So magnitude is equal to the square root of 7 over square root of 58, and that's squared, plus a negative 3 over square root of 58, and that is squared. So this is the square root. 7 squared is 49. Square root of 58 squared is 58. Plus negative 3 squared is 9 over 58. So this is square root of 58 over 58, square root of 1, which is 1. So we confirm that it is a unit vector. Okay, we also have something called standard unit vectors. And all that is j is the y component. And I is the x component. And it's just another way to write unit vectors. So j, so this length is 1. And j is a unit vector, and its coordinates would be 0, 1. I is a unit vector, and that would be 1, 0. So what we're going to do is, it's called a linear combination of vectors I and j. And let's just get into example 4, and I'll show you what that means. So it says write a linear combination of u where negative 2, 6 is the initial point, and minus 8, 3 is the terminal point. So this is easy. You don't have to write the vector or draw the vector, but you could if you want. But we'll just say that u is, so it's going to be the terminal point minus the initial point. So this is going to be a minus 8 minus a minus 2. That's in the x direction. And then 3 minus 6 in the y direction. So this is a vector negative 6 on negative 3. Or we could just write this using I and j. This would be minus 6i minus 3j. So these two things are equivalent, saying the same thing. Okay, last example. Example 5. We want to find 2u plus or minus 3v for u is equal to I plus j. V is 5i minus 3j. So we'll just write it. 2u is going to be 2 times u is I plus j. And minus 3v. V is 5i minus 3j. So we have the 2i minus 15i is a minus 13i. And then we have a 2 times j minus 3 times a minus 3. So 3 times minus 3 is minus 9. So we have a 2 minus a minus 9. And that's plus 11j. So this is 2u minus 3v is equal to that. Okay, so that's it for the first day of 6.3.